In this video, we're going to be covering numbers tables. And in SQL, numbers tables are a really convenient way of mimicking a for loop. We don't have for loops in SQL, but there is a little trick we can use to mimic that. So one thing I do want to do is first, if you haven't created an age column in your users table, please go ahead and create that. We're going to be using that in this video. And then run this statement. This is going to go ahead and update all of the users' ages based on their date of birth. I already ran that. And just to check, go to users and scroll over and make sure that all the ages are filled in. And if they are, you don't need to run this again. Next, you need to download the SQL file along with this lesson and run these two commands. First, we're going to create a table called numbers, and that's just going to have one column as an integer 11. And I always say a table with a single column is useless. And I will say in 20 years of SQL that's true. Numbers tables is the only exception to that rule. So this is the only time you will ever create a table that has one column. And if I run that, it's going to create a table called numbers, and then run your second statement, which is going to insert into the numbers tables the numbers 1 all the way down to 100 consecutively. So after you run those two, what you should have a table here called numbers with the values from 1 to 100, and should say 100 rows. Okay, once you have that, we're ready to continue. So what if I was looking for data to extract to be used in some type of chart or graph, whether it be like a bar graph or a line graph? You'll find out managers love graphs. And again, in other programming languages, you'd probably use a for loop, because along your x-axis, along the left to right line, you'd probably want consecutive data, whether it be for ages or some type of number. And then your data would go up or down the y-axis based on whatever your data is. So here's an example. Say I want to get the sum total of all items purchased grouped by age. And I want the data to be returned as a dollar amount for all of the ages between 18 and 65. So if you think about it, going from left to right, you want to start at 18 and go to 65, and then you want the line to go up and down based on who's purchasing more or less to reflect how much they purchased. And if there's a year, group year, we'll say, I don't know, 19-year-olds, 20-year-olds, whichever year, where no purchases were made, well, there should be a 0. So that way it goes down and reflects that in the graph. Given what we've known, here's what we can do so far. We can select the age and then the sum of the retail price times the quantity from users, orders, order item, and the item table. The reason why we need these tables is age is from the users table, quantity is in the order item table, but we can't connect users and order item together without the orders table. But then we also need the retail price, which is over in the item table. Then we're going to group by age and order by age. And if I was to run this, we would go ahead and see, I forgot to go ahead and change this. This is retail price. That we would get all of the ages. So our youngest purchaser is 16 years old. Our oldest is 76. And we'd get the sum item price, which is how much they purchased for that age group. So for everyone who's 21, they only spent $5,300, while the 20-year-olds spent $62,000. This is good, but we may have a little problem in here. And as you look through the ages, what you may see is that some of them may skip, meaning I have the 63-year-olds, but the 64-year-olds are gone. And then we go to 65. Well, I'm going to go ahead and intentionally increase this problem. I'm going to update all the users who are 23 to 22 and all the users who are 24 to 25, just to make a point here. And now if I rerun this statement, I'm now missing 23 and 24-year-olds. So this query does work. However, it's missing the age groups if no one from that age group has made a purchase. This causes a problem if we're going to go ahead and turn this into a graph. And by the way, whether you work in C or PHP or Swift or Java or pretty much any language, there's always going to be a function where you can get your data out like this, put it into the function, and it will generate a graph automatically. You just have to go ahead and get your data out correctly. So here, being that the ages are skipping, we're kind of met with a problem. We need to go ahead and have them be consistent and consecutive. So here's what I'm going to do. I'm going to start off by using that numbers table and say I'm going to select n as age from numbers where n is between 18 and 65. And if I run that, I get my 48 rows, 18 all the way down to 65. So I have the first column I want. Next, I need to go ahead and get the second column. Well, when I ran this, I have my second column and it does match up to the ages. Perhaps we can join these two tables together to get the results we want. Now, I'm going to go ahead and just remove this for just a moment here. So I took the query we have above here and I've pasted it down below. So I'm going to highlight it and I'm going to run it. And again, I need to modify that item price to retail price. My apologies. And again, we have all of that info missing a few of those ages. Well, I'm going to put it as an inline view and call it order sum. So from here on out in the query, I'm only going to reference order sum. I'm not going to reference anything else in that query. Well, if I take numbers and left join it to order sum, remember the numbers is just giving us the consecutive 18 through 65. And left join means get everything from numbers and then join it to this. But just because it doesn't exist here, meaning we're joining age to n from numbers, I still want it to be returned. I'm going to lower this a bit so you can see, and I kept that bottom part in where we're only getting between 18 and 65. Well, because we're doing a left join now, what you'll see is there is 23 and 24, which was missing from this query. But because we did that left join, that sum item price comes back with nulls. Let's see if there's any more nulls in here. As I scroll down, okay, 64 is a null, and 23 and 24 are nulls. And this may change depending on what date you're running this query. So ideally, we want to change those nulls with zeros because no one at 23 years old purchased anything from our site. That's when we can go ahead and add in a case statement to say when the sum item price is not null, then we'll return sum item price, else we'll return a 0. And if I run this again, I want to get it all on one page here so we can see it. I now get my consecutive 18 to 64, and instead of getting those nasty nulls, I get zeros. So I can take this data now and take it out and put it into a function and very conveniently create some type of line graph, bar graph, something to represent this. So here's an example of what it would look like if I was doing this in some type of maybe a C# or some other type of language. I would have looped from 18 to 65, and I'm using I and incrementing I with each loop, and then in here perform some type of query. And this is called pseudocode. It's not real code. You can't run it. But I'm basically saying I would perform some type of query to get the sum of the retail price times the quantity from users where the age equals whatever I is. And I'd go ahead and bring it back. The problem is I'd have to do a query for each age group. So I do a query for my 18-year-olds, my 19-year-olds, my 20-year-olds. That's really not what I want to do. In here, I'm able to just run one query. It's going to be a lot quicker, and that'll go ahead and return all of the data. Let's see here. We created that, and we were able to do the inline view, and we were able to put in the, let's see here. Yep. So again, just to reiterate, numbers tables are really just a convenient way to do mimic a for loop. Make sure you go ahead and select your first column first, do something like this, and get your first column where you want it to be, whether it's age, whether it's year, whether it's cylinders in a car, whether it's any of the numbers, and then go ahead and either use, like I did here, an inline view. You can also perhaps use a scalar subquery, but you can leverage that number table to go ahead and pull in that data.